Yeah, it took a little while to connect, but we made it.
Yeah, there it is.
Welcome to the advanced session on document ingester and decision models with knowledgeable aware consultant Steve Boisvert. So take it away. I know you got a lot to cover.
Yeah, thanks, Amy. Yeah, so this session, we're going to cover this new feature called the document ingester. We talked about it last year. I believe we touched on it a little bit, but I don't believe we showed much of it at all. It was still kind of in its infancy at that time. Since then, it has been released in some of our Oros IQ applications, and we want to take this time to kind of detail a little bit more what the doc ingester is and how it functions, and give you guys a better idea when and where you can use it. So I am going to start off with a brief presentation, give you guys a little background on the application. So there's my old picture when I had a tan and more hair. All right, so let's kind of go over a little bit about the doc ingester. So there's a lot of I guess, mystique about this new feature. Actually, I had a customer I was working with on a particular project that IM'd me and said, can you show me how to use this mystical document ingester that everybody talks about? And it's really not, that mystical, but there's some stuff we need to discuss. So some of the learning points today is, what is the document ingester? When should you use this functionality? Who can use this functionality? And then in general, how does it even work? Try to eliminate that mystique about this feature. A little overview about the document ingester. It's still currently a beta feature, and I kind of want to stress that, it is still beta. Even though it is released in our tool set, it's a beta feature that is meant to use an AI-enabled tool set to extract text and images from PDF files. During that extraction, it can also assist in creating and categorizing those knowledge packets, for reuse and provisioning into other workflows. So how it works is that the AI technology uses the document structure, and we're going to look at this. And I want to show you some samples of good document structure, or at least tested documented structure. It's going to use that document structure and formatting patterns. So we're going to look at, the different patterns within these documents, the fonts and the style. And what it does is it uses those patterns to kind of isolate the key criteria that you want to turn into a knowledge packet. So when we really started working on this concept, we had a core use case in mind. And that was really to do kind of the customer requirements or specification compliance or regulatory compliance workflows. These workflows often, involve large PDF documents, hundreds of pages that, individuals often break down manually. They copy paste into an Excel file to help them evaluate that knowledge or kind of review whether or not different requirements have been taken care of. And so we wanted to create a tool where we can quickly bring that information in, parse out this information, and categorize it in a way that could be useful. And to kind of give you another view of our intent, I have this little conceptual model, and I want to make a distinction here. There's actually two parts to what we're going to talk about today. So with the document ingester, we're going to bring in PDF files, right? I'm going to show you how we bring those into the document ingester. And the first thing we're going to look at is how it basically shreds that document, how we can use that formatting to shred that document and create knowledge packets very quickly. But for those of you that have used Oros IQ, the knowledge aware concept, you know that just having these knowledge packets really is enough. You just created a database. There's really a key element in that we need to be able to categorize. We need to apply intelligence to those knowledge packets to classify them, to know when they need to be reused, or how they need to be reused, who needs to reuse them. So we need to classify that information. So there's a second piece that we're going to look at, and we call it IQ suggestions. And I'm not going to get into detail on how we set up the IQ suggestions extended elements, but we're going to look at how they perform. I'm going to run an example for you, and you're going to see how they work. But basically, in a nutshell, once we parse this information and we have these knowledge packets, an AI tool, an AI model is going to look at the contents of that knowledge packet and it's going to try to predict how to tag or apply metadata to that, that particular knowledge packet based on information that we've provided the tool, some learning information. So previous projects we've worked on, so we talk about this a lot, you know, how can we use that information, you know, going through this process, how a particular knowledge packet gets used plays a big role in, you know, how it's going to perform in the future. And same thing here. We can utilize other information in the system to kind of predict where new knowledge needs to, you know, be provisioned to. And we call that IQ suggestion. So two parts, the document ingester parsing and then the IQ suggestions. So let's kind of get in real quick. I want to show you one of the supported use cases. So we call this alphanumeric structure. And really what this is if you guys use Word at all and you use multi-level formatting, documents that have multi-level formatting work really good in the document ingester because, again, the document ingester looks at that structure, looks at the formatting cues within a document and allows us to identify how we want to break down this structure, where we want to create knowledge packets from. So for example, this particular document has several different, you know, levels. We have this top level here that has a particular font color, size, type, location. We could use that as a parsing cue, right? We could say, basically create a knowledge packet. Every time you see this kind of structure, everything below it becomes a knowledge packet until you find another one of these at this level. Or with this particular document, there's a second level. Maybe we want to create knowledge packets at the second level, where everything between this level, like this particular heading and this heading, becomes a knowledge packet. So basically everything in the middle could become a knowledge packet. Depends on the level of granularity you want your knowledge packets to be. Or, because it has a third option, we can go all the way down to the most granular level in this document, and we can identify the numerical formatting that separates each one of these particular requirements, and we can make that our parsing cue. And then every one of these particular items becomes a knowledge packet throughout the document. So we identify it on one page, it remembers that parsing cue, and it'll execute it for the whole document and create this ability to generate knowledge packets very quickly. So this alphanumeric structure, this multi-level formatting in a PDF works really well in our current document ingester. Another one that works really well, and it's a very common use case, especially with like military standards or kind of any kind of hierarchical structured requirements document. What we can do, again, we identify parsing cues, right? Where do we want to break this information down? And within the hierarchy, this one's even better because we have these different levels. You know, we have the top level, level 1, you know, the scope, at that top level of the hierarchy. Or we could break it down at the sub level, the second level there, you know, at the 2.1 or the 3.1 level. And then every one of these particular items becomes a knowledge packet. Or we can go down to the, you know, the third level, fourth level and fifth level. However deep you want to go in a hierarchical structure, we can detect the parsing cues based on how we set it up and either go to that level, or we can incorporate all three of these. So maybe we want to have every one of these levels become a knowledge packet, and I'm going to show you a demonstration of how we make that happen. Now with documents like this, another thing I want to point out is oftentimes we don't just need the content, right? We don't just need these requirements, for instance, but there's also critical information on the page that we want to be able to apply to the knowledge packets we create. And what I mean by that is there's metadata in these documents, like the item number, for instance, or the category, or when this particular publication was released. Maybe I need that information, and I'm going to show you how we can collect that information, this metadata, and tag it to all of the requirements or all of the knowledge packets that get created from this document structure. And lastly, maybe you have a document that doesn't have structure. and that's okay. And we do have a method that we can use to manually select. So we kind of just rubber band, we create a bunch of little boxes around, the text that you want to turn into a knowledge packet. And for however many boxes you have, those things become knowledge packets, and you can do that too. Although I'm not going to do a demo on manual selection, you're going to see that's part of the tool set. So those are the kind of the three primary ones I want to discuss. But I also want to let you know, because I get this question all the time, what doesn't work? And we know that there's limitations in the tool set. Often we say, oh, we have this document gesture, we can bring in information really quickly, and everyone's eyes light up. But there's some cases we just don't handle well yet. We're working very diligently to correct some of the behaviors we're seeing. But two of the most common unsupported use cases at the moment is table data, right? So for instance, the information on the left here, a lot of useful information in there. I'm sure there's a ton of information that could be generate into a value table or a good knowledge packet. But unfortunately, when this table, which was probably in Excel or Word at the time, gets converted into a PDF file, it loses all that structure. The PDF is unaware of what's a column, what's a row, and what we end up with is a giant blob of text. And so it's not useful at the moment anyway, and we're working on some solutions to this problem. But if you're seeing the document ingestion, you're thinking, I have all this documented information from my engineering test results and stuff that would make really good knowledge packets. If it's in kind of a table structure at the moment, it's best to kind of hold off until a future release of Oros IQ when we're able to handle that structure to put those into knowledge packets. Another one I see constantly, we work a lot with shipbuilding companies, and they have to apply military standards. And oftentimes they're like, yeah, we have all these PDFs of mil standards that we need to apply. And we open up the file and you see little binder holes, and you realize it's a scanned document. This information isn't readable in the document ingester. It's a picture, and we're not able to collect that text yet and create a knowledge packet. So just a couple instances of unsupported use cases just to make you aware. Now, who can use the knowledge or the document ingester? It's a community of practice admin feature. So only the community of practice admin can see this. So if you're a community of practice admin, you go to your admin screen and you open up your settings here, and you come down to the document ingester, which is shown here in the left panel. And if you see a screen that looks like this with create new and import template, then your document ingester is set up. If you come in, you hit the document ingester and you see anything else other than this, then you're going to need to contact your supporting application engineer or your IT representative and get that corrected. There's some setup that needs to be involved, and we need to enable those features.
Steve, quick question from Nicole.
Yep.
Can you use Excel as a document?
Good question. And at the moment, no. It only works with PDF files.
All right, thanks.
Yep. So I want to do two quick demonstrations. If we have enough time, I'm going to try to get through both. So one is that alphanumeric structure, and I want to show you that structure being parsed and how we can predict with an AI model which deliverable these particular requirements are related to with the IQ suggestions enabled. And the second one is I want to go through that navsea standard item document. This is a huge document, 790 pages long. And we're going to see how the tool breaks up a hierarchical structure and how that gets parsed and how we can collect some metadata from within the document. So let's hop out of here. We're going to hop into Oros. And the first one we're going to do is the specification compliance, right? We have that document. Now, the first thing you have to have a community of practice, because the community of practice defines which elements, which extended elements you have, who's author. You have to be a community of practice admin to even run it. So you need to have a community of practice to read this information into. So I have a community here. There's no kpecs in it, 0 kpecs. We're going to go to admin. We're going to go down to basic, content management, document ingester. And what we're going to see is I'm going to create new. So we can create and save templates. So if I need to run a document multiple times, I can save that template. I don't have to recreate it again. It'll remember the parsing cues, and it'll parse that information and do exactly what I told it to do the first time. But I haven't set one up yet. So I'm going to create a new one. So it's asking me which PDF file, right? So I'm going to go into my folder here. We're going to bring in our maxpower construction specifications. And you can see I have it here. There's 21 pages, right? I can click through, and the contents don't really start until page 4. So I'm going to tell it there's 7 steps here I need to complete. The first one is how many pages do I want to do this on? And we're going to tell it to go from page 4 to page 10 for today. I'm trying to make it a little quicker. And apply. So it's going to do this page and on. Now, the next step is to ask me, is there a header? Because what we want to try to do is we want to try to train the tool on the sections of the document that we want to exclude. Don't look for any kind of text in these areas. So that was the header. I hit apply, and I get the little green check mark. That one's done. Is there a footer? There is a footer. It's way down here. You know, disregard any text in this area. Apply. So now we get to the most critical step, applying the kpec boundaries. Now again, I can do this on any page. As long as I have representative data on a page, I can set up my boundaries. Now I mentioned there's 2 ways. We can kind of automatically parse, or we can manually select. We're going to automatically parse. And to do that, the first step is identifying which region of the document holds the text that I want to turn into a knowledge packet. So I'm kind of setting my left and right boundaries here. And all I need is a sample, again, from any page within the document. So I've defined where my description is going to come from. Next, I got to apply a boundary structure. There's 2 types that currently work in the document ingester: alphanumeric, which we've talked about, and hierarchical. So this document is clearly alphanumeric. So there's some options I can do. Do we want to collect basically the structure and store that on an extended element? And for this example, I'm not going to. What do we want the title to be? We have options. Do we want it to be the first sentence? Do we want it to be the boundary structure? Or do we just not want a title? We're going to leave it as first sentence. What is the text like in this section? It's uppercase or lowercase or mixed, and it's mixed. This is all mixed case. And then I have to select a representative structure, right? And I want to go down to the lowest level. I want this to be a knowledge packet. So I want each one of these to be a knowledge packet. So I'm going to say, here's my sample right here. And I'm going to say apply. So my 4th section is done. Now it's asking me, are there any extended elements? And I do. I want this to use the IQ suggestions to predict which deliverable each one of these requirements are related to. And again, there's an AI model that's been developed on past data, so past projects I've executed, where it's going to compare the contents of these knowledge packets, and it's going to try to predict, you know, is this related to this deliverable or that deliverable? And when I go on to this element, which is called standard deliverable, it's a global extended element, and I'm going to say enable suggestions, which means connect it to the AI model. I hit apply, I get a check mark. Next, it's asking me, are there images? And if so, where's the image title, the description? Is it at the top, bottom? This particular one doesn't have any images, so we're just going to say apply. And now we're ready to process the PDF file. So I hit the little green button. I get my loading, please wait. And in a matter of just a couple seconds, it parsed out all of those items out of that document from page 4 to 10, right? So it ended up with, what did it end up with? 35 knowledge packets. Not only did it end up with 35 knowledge packets, but you can see here's the kpec title. We have a description that it pulled from the document. The standard deliverable, so here's my extended element. These ones are saying it's not required. If you kind of go down, this was telling me it's related to the general arrangement drawing. This one's related to the vapor recovery system. And so basically the AI model predicted which deliverable each one of these items were related to. And it's telling me here. So let's kind of go down to this this welding one. So if we look at, it's kind of hard to see, the welding shall have a minimum, right? It's telling me this is part of the welding schedule. And if I look, if I click into that, it's telling me that the model's predicting with 88% confidence that this particular item is related to the welding schedule. And I can see, kind of that level that model is telling me is related.
Steve, good time for 2 quick questions.
Sure.
Christine is wondering, you mentioned this was only beta. What IQ version do you plan on rolling this out to us?
That's a good question. And we have a project in the works right now where we're working with the National Shipbuilding Research Project program to further the development of the dock ingester. And our plans are to have a lot more functionality in IQ 10.
Great.
So it'll be March.
Okay, March of 2022. So Thomas is wondering, if there were images in the text, would they be added to the kpec?
That's exactly correct. And what we would see, if there was an image, so let's say, for example, the document had an image somewhere between 1 and 2. What would have happened is that multimedia image would have been shown here and tagged to this, this knowledge packet. So you can see, once we parse it, we get a representation of the source document and where that knowledge packet came from. You can kind of see that green box showing, here's where from this document this came from. And if I process this knowledge, I have the ability to save a template. So if I want to execute this again and again and again, I save a template, and then all of those parsing cues I went through are saved. But for today, we're just going to create without saving the template. We're going to let this process, and then kind of
ask another question.
Yeah, go for it.
You told me to interject when it's processing. Okay.
Yep.
Justin just chimed in. Does the AI model already exist, or does it start at no intelligence and improve with unique customer use?
You need to have some there needs to be some data there before you can create the model. So you at least need one knowledge packet before that model is created. Once that model is created, though, every new knowledge packet that's created contributes to that AI model, and the accuracy continues to increase over time.
Cool. And you got a couple minutes left. I'm just going to leave my camera on. Go for it.
Perfect. All right. So all I've done is we've processed this in and kind of give you an indication of performance. I've kind of been measuring, doing some benchmarking. So the parsing usually takes, just so you know, about 1 second per page to parse and give you the results table. What I found is it also takes, once we're trying to create these knowledge packets, about 1 second per knowledge packet to create knowledge packets. So if you have a big document, like I mentioned, that navsea document, 790 pages, I parsed it, it was 3,291 kpec. It took forever to create. So a best practice, just so you know, is to chunk it. Save a template, chunk that data, do it in smaller pieces, and it's much more manageable. So I want to show you real quick a knowledge packet that we created, right? We have one here. You can see that the source, where it parsed the data from, is stored here. Yeah, and then our standard deliverable is also tagged on this particular item. So if we wanted to, since it's categorized, we could quickly turn these knowledge packets into an assessment, provision that information off to the individual that is responsible for creating the welding schedule. He would be completely aware of all the requirements that he needs to be aware of for this particular project that relate to that welding schedule. How much time do we have left?
Did you get through it? I mean, 10 seconds officially, though you can go just a little bit
No,
over.
that's okay.
Okay.
I guess one thing, if I wanted to get through the hierarchical structure and show you how to parse that and how we can collect metadata. If you want to, reach out to me after the conference, or get a hold of your supporting application engineers or your business development individuals that you might be working with, and we can arrange a briefing. We can go over how some of these features work, and we can do a much better job, spend a little bit more time going through these features.
Yeah, and then Nicole was just asking, does the AI model live in the COP or the system?
It lives in the system. Yeah, because it's Nicole, just so you know, the AI model currently only works with global extended elements. That way we can monitor which community of practices are consuming those elements. That way we can kind of monitor what data is going into the model, and making sure that we're not introducing a bunch of noise. So it's system level. We enable it in the global elements, and we then, you know how global extended elements work. We got to tell it which community of practice to participate in.
Great. So that wraps up our third advanced breakout session for the day. Next, we'll head back to the main stage at 3:15, where Josh Cullis will lead us through OROS and OROS IQ, walking the walk. See you there. Thanks, everyone.
Thank you.